Mm, mm, mm. How are you guys? Uh, I'm going to be presenting on transaction management and concurrency control. So it's the last chapter, Unit 5. Okay, first things first. It's not like I'm famous. Ndonzi Samanga. Samanga. Mm. Okay, so we are starting on transaction management, right? Yeah. So what is a transaction? A transaction is a set of steps completed by database management system to accomplish a single user task. Then must be either entirely completed or aborted. No intermediate states are acceptable. So here we've been given a diagrammatic representation of what they are talking about here. So we've got a variable x to which they are assigning the value 40, so that is the consistent state. Then we have got this operation here. That's transaction A, and this is the final state. Okay. Um, then the transaction properties. These are also called the asset properties of a database. Then there is atomicity. Atomicity. All transaction operations must be completed. Incomplete transactions must be aborted. Uh, so it means each and every operation that is being carried out should be completed. So there should be no intermediate states like once a transaction has been started, it's either it is completed or it's averted. So there is no intermediate state here. Then there is durability. Once a transaction is completed, its changes are made permanent. That's durability. Then we have serializability. Conducts transaction in serial order. That is just transaction in a sequential order, whatever, in a progressive way, in whichever way you would want to put it. Then we've got as important in a multi-user and distributed databases. We're going to have an example on, I think it's on the next part in my presentation. We'll talk about that later. Then there is isolation. Transaction data cannot be used until its execution is completed. That's isolation. We're going to explain more on that one later again. So these are the asset properties. We've got atomicity, durability, serializability, and isolation. Then there is transaction management with SQL. We're going to talk about this later. Then there is the commit rollback. User initiated transaction sequence must continue until commit statement is reached. Rollback statement is reached. Commit statement is it simply means that you are committing to the changes that you have made. Like you have been writing to the database, you are committing to the changes that you have been uh, making to the database. Then rollback, you are vetting the changes that you have made to the database. So I think it's self-explanatory here. Then end of a program reached program. Okay, we, let's look at this one on the next part. The next part. Okay. Currency control. I'm going to okay. What's happening? Currency control. Content concurrency. So these are the things that are going to be covered. We've got concurrency problems, concurrency control, and concurrency control approaches. Then concurrency problems. Data integrity and consistency problem may arise when several transactions are processed simultaneously. Data integrity and consistency problem may arise when several transactions are processed simultaneously. That means to say it's in a multi-user database environment, which means we've got two or more users that are accessing the database at the same time simultaneously. So there may arise problems of data integrity and consistency. Like one user wants to read from the database and another one wants to make an update to the database. So there are problems that arise there. Then we've got an example that we have been given here. Then as the Ali and Siti, whatever, I do not know if my pronunciation of those names are correct, have a joint savings account in a bank and each has been issued an ATM card. It may happen that both Ali and Siti withdraw money at the same time in two different locations. So we have been given this table. So Ali's transaction time one, read account balance is equals to 1,000. What currency is that one? I do not know. So he has withdrawn $1,000, and read the account balance is $1,000. Then withdraw $600. Balance is equals to 400. Uh, $400. Right balance is equals to $400. That is the amount that is remaining in the account. Then we've got withdraw $700, insufficient funds. So here we've got $1,000 in the account. Then we are reading the balance is 1,000. Then we have withdrawn $600, which means the balance that is remaining in the account in the bank is $400. So right balance is equals to $400. When you want to withdraw funds, so this is the last transaction that has happened time 3 year. So in the account there is $400. So we cannot withdraw $700. This is the kind of things that happen when you have two people that are accessing the same database at the same time. That is why we are going to talk on locking. We're going to talk about that. We explain more on this one. So when someone is editing the database should lock any other entry from another user, like access. It should deny access to the other user, so that they may not arise inconsistent problems. So we're going to talk about that in on locking. Then concurrence control. This type of problems are caused by lack of coordination with two transactions. Like we should read. Let us say on this example that we have had on the bank accounts, we are reading the amount that is in the bank. Then so the process should be concurrent. Like you read, you make a change, then you update. You are committing to the changes. So if somebody is trying to make a change when someone is reading from the database, he is going to read the change. Okay, the change may be lost when somebody is trying to update the database, yet somebody is also accessing the same database and making changes. So there arise a problem there. Some data will be lost, or you are going to read a value that you do not expect. Like here, this guy is assuming that in the account there is still $1,000, yet there has been withdrawn $600. So here on Citi's transaction, it is saying that there is insufficient funds in the bank. This is the problem that arises. So the database management system should deny access to one of the users depending on what they are doing on the database, whether it's reading the amount or making an entry into the database. So maybe the database management system does not provide concurrency control. Concurrency control refers to the coordination of execution of multiple transactions in a multi-user database. We've talked about this one. Then three problems associated with concurrent processing: lost updates, that is what I was talking about, uncommitted data, and inconsistent retrievals. So we are going to talk about that one. Let's move on to we've got a scenario here. So we are going to explain on lost updates, then on uncommitted data, and then inconsistent retrievals. So we've got scenario one. Assume that the customer balance is 500, and second transaction T1 and transaction 1 and transaction 2 um attempt to update the balance at the same time. You see the problem. So we've got a table there. Transaction 1, action deposit 200 in the bank. There was already 500, so we are adding 200 to the amount that is in the bank, which gives us $700. Transaction 2, withdraw $100. So balance is 700 minus 100, because we have made a withdrawal of $100. So the balance $600 here. So the serial execution of this transaction yields the correct results. Balance is equals to 600. So here we have had two transactions happening at the same time. So here there was no problem, because we are adding $200 $200 to the amount that is in the bank. So the balance 700. Then we have made a withdrawal of $100. Then we've got $600. Let's hear what they are saying here. So a transaction requires several steps, such as reading, modifying, and writing. These steps should happen separately. Like there should be no two users that are performing the same things at the same time here. Then it must be in correct sequence. So it should be reading, modifying, then writing. So it should be sequential. That is what they are saying here. See the correct sequence for the previous transactions. Okay, that is lost updates. Then we've got another table here. We are continuing with the scenario that we were given uh, on the slide before this one. So we've got transaction 1, read balance 500. Transaction 1, balance is equals to 500 plus 200. Write balance 700. Read balance 700. Balance is equals to 700 minus 100. Write balance 600. The schedule below the scheduler below shows incorrect sequence leading to lost updates. Read balance 500. Read balance 500. Balance equals to 500 plus 200, 700. Balance equals to 500 minus 100, 400. Right balance. So you see, got we are reading the balance, right? We had 500 in the bank, $500 in the bank. And that one is adding balance. So he's adding $200 to the bank. Then we have $700 in there. Then transaction 2, balance. So this is happening simultaneously, like T1 and T2. So there is read balance for T1 and read balance for transaction 2. So this is happening concurrently, simultaneously. So you see, Gucci, this 700 has not been saved, because it is the update is being made when somebody is accessing the database and making some changes also. So 700 has been lost here. So we have got right balance 400. So 700 has been lost. That is what is happening. So that is why the steps should happen one after another, progressively. So this is what we are going to be talking about on locking. So one user here should be denied access to the database. Then we've got uncommitted data. The second problem on our list. Data are not committed when two transactions, transaction 1 and transaction 2, are executed concurrently, and transaction 1 is rolled back after transaction 2 has already accessed their uncommitted data. This violates the isolation property of transaction. Those are the properties that we've looked at. Then there is uncommitted data. We've got a table here. Deposit 200. Balance is equal to 500 plus 200. Rolled back. Then withdraw 100. Balance equals to 500 minus 100. Balance equals to 400. This serial execution used the correct results. Balance 400. Then on this one now, we are reading the balance 500. Balance is equals to 500 plus 200. Balance, right balance is 700. Then there's been a rollback. Rollback, which means the process has not been completed. That is you still remember on the acid properties, the acid properties that we looked at, there was atomicity. It's either you complete the process or you have it. That is the rollback here. So rollback is just an aversion, like you are discarding the changes that you have made. So 700 there. So by rollback, we are going to back to the value that we had before, which is 500. Then on the next one, we are subtracting read balance. Okay, we read balance first, which is 500. Then the balance that is now in the bank is 500 subtract 100, which is 400. So the right balance is 400 here. Then on this table, the scheduler below shows incorrect sequence leading to lost updates. Lost updates, which means okay, let's see what is happening here. Read balance 500. Balance equals to 500 plus 200 to give us a right balance of 700. Read balance uncommitted data, which means uncommitted. It simply means that the process has not been completed. Therefore, it's another rollback. So therefore, there is a rollback here, 500. So we are reverting to the value we had at first, which is $500. Then right balance lost update is cost to $600. So we are subtracting $100 from $700 to get $600. Is rollback one. Okay, the right balance 600. We have subtracted 100 from 700 to give us 600 here. So right balance was 700. Read balance and committed data has not been saved. There's a rollback here 500. So we are subtracting 100 from 700. We get 600 here. Okay. Then inconsistency retrieval occurs when a transaction calculates an aggregate or a summary function, e.g., sum of a set of data, which the other transaction are updating. You see, there are two concurrent operations here. The inconsistency happens because the transaction may read some data before they are changed and read other data after they are changed. Then we come to locking. Locking, if one user is updating the data, all the other users should be denied access to the same data, so that so there should be commission of data first before access from another user. So when someone is updating or is writing to the database, the DBMS, the database management system, should deny access. Like when you want to make a change to the same data, the first user has to complete his process first. So he has to change the data first before the other one can make changes. Otherwise, we could lose data in that process. Then time stamping. A unique global timestamp is assigned to each transaction. So time is being assigned to each transaction here. Then a locking. A lock is a mechanism to control concurrent access to a data item. Let us say on the table that we had here, we had two users that are trying to access the same data. So there should be a mechanism that controls that simultaneous concurrent access to the data item. So these users want to access the same data item in the database. So they should be given time. And it here, we've got it. The time stamping. I think we're going to talk about that later in the slide. So a lock is a mechanism to control concurrent access to a data item. Data items can be locked in two modules. There is exclusive X mode, data item can be both read as well as written. Xlock is requested using log X instruction. Shared S mode. So there is the exclusive mode and the shared mode. Data item. So on the exclusive mode, we can read and write. Then on the shared mode, data item can only be read. Slog is requested using the log S instruction. Log requests are made to concurrency control manager. Transaction can proceed only after request is granted. So that is the logging of the database management system. So it denies access to one user so that the other user may finish what he is doing to the changes or the processes that he is performing on the database. Then logging continuous log compatibility matrix. So we've got true false. So S is given access, X is not given access, then X is false, false. Then a transaction may be granted a lock on an item if the requested lock is compatible with locks already held on the item by other transactions. Then any number of transactions can hold shared locks on an item, but if any transaction holds an exclusive on the item, no other transaction may hold any lock on the item. If a lock cannot be granted, the requesting transaction is made to wait till all incompatible locks held by the other transactions have been released. The lock is then granted. So, example of a transaction performing locking, we've got lock SA, read A, and lock SB, read B, and lock B. Display A plus B. Locking as above is not sufficient to guarantee serializability. If A and B get updated in between the read of A and B, the displayed sum would be wrong. Then we've got a deadlock. A deadlock, I think this one has been cited also on the course outline. So consider the partial schedule T3 and T4. Log X B, read B. B is equals to B minus 50, write B. Then look and say, okay, what are they saying here? Neither T3 nor T4 can make progress. Executing lock SB causes T4 to wait for T3 to release its lock on B. So T4 should wait until T3 has released uh, its lock on B. While executing lock XA causes T3 to wait for T4 to release its lock on A. So it's just a matter of assigning a chance to each transaction here. So one is denied access at a certain instance, and the other is given access at a certain instance. So it's a matter of denying and accessing and one can denying and accepting access to the database, so that concurrent operations do not result in data losses. Then a deadlock. Such a situation is called a deadlock. To end a deadlock, one of T3 or T4 must be rolled back and its locks released. A rollback, which means the changes that are being made by the other or the writing that is intending to be made by the other user should be affected so that the ongoing updation can complete. Then methods to control deadlocks. Deadlock prevention. Transaction requesting a new lock is aborted if there is a possibility that it might cause a deadlock to occur. Um, Transaction requesting a new lock is aborted if there is a possibility that it might cause a deadlock to occur. Okay. Then deadlock detection. The DBMS periodically checks the database for any deadlocks. If it exists, um, if a if exists, it aborts one of the transaction. Okay. Deadlock recovery requires each transaction locks all its data items before it begins execution. So each transaction should lock its data items before the next execution. Then time stamping is also on the so cited on the course outline. Each transaction is issued a timestamp when it enters the system. No timestamping at sure. If an old transaction T1 is timestamp TSTI, a new transaction TJ is assigned timestamp such that TS is less than TSTJ. Timestamping T1 is less than timestamping TJ. The protocol manages concurrent execution such that the timestamps determine the serializability order. That is the end. So if there is anyone who's failing to understand anything here, I will be in the group from now actually, and even after 7, because my presentation was supposed to be uh from 7 p.m. So from you can ask me questions from now to Bathrana. So thank you guys.